Hello friends, in this video we are going to discuss how to run multiple linear regression analysis with the help of our software. Multiple regression is used to predict the value of dependent vector based on certain independent vectors. And all the vectors should based on numeric in nature to run the multiple linear regression analysis. There is one more major assumption is that all the vectors should based on numeric and there is a linear association exist among dependent and all independent vectors. To understand the process, we'll take inbuilt data available in the R that names as empty cars. So first we'll open this data and read this data, understand this data. So I'm using the script area, I'm using the function data sets and open data empty cars. Alt plus enter. So now you can see the various vectors which are available in this data set. We'll use MPG as a dependent vector and DISP, that is displacement, HP, D rate, that means real axial ratio, weight, and QSEC means performance measurement acceleration as a independent vectors. So MPG is a one dependent vector and DISP, HP, D rate, weight, and QSEC. The 5 independent vectors will be used to run the multiple regression analysis. So I create data equals to empty cars for the subsequent functions. And now, before going to run the multiple regression analysis, first we'll check the assumption about linear association among the vectors. So to examine this, we plot a matrix scatter plot between the dependent and all independent vectors. So I'm using the command pairs MPG is a dependent vectors and DISP HP D rate weight and QSEC, these 5 as a independent vectors. I'm using the data equals to empty cars. Here data equals to empty cars is important to verify, important to mention, because the R would understand that all these vectors are a part of empty cars, so they will recognize these all vectors with the help of in the data empty cars. So just make it alt plus enter, and in the plot area you can see the various scatter plots relationship among all the vectors. So this is, you can see that all the relationship, they are linear associated and somewhat is negative and somewhat is positive. So if I see the scatter plot between MPG and DISP, this is negative in nature because the direction is downward. It is linear but direction is downward. But instead of that, if I see the relationship between this DISP and HP, so this is displacement with the horsepower, this is upward in direction and it is a positive. So you can see that various relationships are there which are linear associated among each other, so we can run the multiple linear regression for the further examination. So to run the multiple regression analysis, I'm using the command LM. So LM stands for linear model. So first I'll create the model regression 1 and I'm using the function LM, stands for linear model, and this is MPG is dependent vector, the sign of tilt, and DISP plus HP D rate weight and plus QSEC. All these are independent vectors and the data equals to empty cars, and now alt plus enter, then retrieve the result of regression 1. Alt plus enter. Then in the console area you can find out the first one is the intercept, that means the constant a, and then you can see the various coefficients of independent variable for DISP, HP, drate, weight and Cusack. The values are 0.008 for DISP, minus 0.02 for HP, 2.01 for drate, and for the weight it is minus 4.3 and Cusack it is 0.64. So we can see that for HP and weight, these are the negative coefficients are there. It means the HP and weight, these are negatively associated with the dependent vector MPG. Now in the plot area you can see this one, HP and weight. So if we see the HP with MPG, so this is negative because these are the downwards, and second one is the weight with the MPG. So this is weight and this is MPG. Again, these are negatively shown because the direction is downward. The linear associated, but the direction is downward, so that indicates a negative association between these independent variables to the dependent vector. So now these coefficients are used to draw the multiple linear regression analysis equation. So the formula for this equation is y equals to, this is a plus b1 x1 plus b2 x2 b3 x3 b4 x4 and b5 x5. So now let's see y equals to MPG. So this is MPG equals to the value of constant. So what is the value of constant? The value of constant is 16.53. Now plus 0.008, this is the value of DISP. Now HP is the negative, so I'm using the sign of negative. This is minus 0.02 and the value is HP. Then D rate, the coefficient of D rate is 2.0, so this is 2.0 D rate. Weight is negative, so this is minus 4.3 weight, and Cusack is positive, so plus 0.64 and this is Cusack. So if you put any value for displacement, HP, D rate and Cusack, you will be having a value of MPG. So in the other words, we can predict the value of dependent vector MPG miles per gallon based on any values of independent vector DISP, HP, D rate, weight and Cusack by putting in this equation. So in this way we can predict the value of dependent vector based on certain independent vector. So this is one application of multiple linear regression analysis. Now second, we can explore furthermore statistics for this regression model 1. So what is the command I am using? This one, summary, and our model is regression 1. So we are going to explore more information about this model. So now you can see, as we discussed in the simple linear regression analysis in the previous video, the same results will be having in this multiple regression also. The first one is the residuals. So if you see carefully, if you see the residuals, you can see the minimum difference in the residual is minus 3.5 and the maximum is 5.4. Actually residuals indicate the difference between the observed values and the predicted values based on this regression model 1. So we can see the difference is not too much in the residuals, it maximum difference only 5.4. So the regression 1 model, which is predicted by based on this equation, is good enough to predict the value of dependent vector. Now the second important specifications are the coefficient. Now intercept, a value of a, which we have already computed in the previous command, and the coefficient of independent vectors for DISP, HP, D rate, weight and Cusack, we already computed in the previous command as we have used the LM function. But the important point is that in this summary results, we will be having a certain t values certain t-test values along with the respective associated probabilistic values. As you can see, I highlight these all values. So these are the values: 0.7, minus 1.3, 1.5, minus 3.5 and 1.3. So these are the associated t-test values for all the independent vectors, and you can see the probabilistic values, p-values. So now in this case, the p-value is only significant for the weight. And what is the value? The value is 0.00158, that is significant at 5% level of significance. Rest all the p-values of DISP, HP, D-rate and Q-sec, these are more than 0.05, so all these values are insignificant. What it tells actually, it indicates that amongst these 5 independent vectors, only weight is the one independent vector which significantly affects the miles per gallon, which significantly affects the mileage. Rest all the independent vectors, these are non-significant due to their higher p-value, that is greater than 0.05. So the summary command first tells us the information about residuals. It means the difference between the observed values and the predicted values based on this regression model. Second, it indicates the constant A, intercept and all the coefficient of independent vectors. Along with that all coefficient of independent vectors, it also indicates the t-test values and the p-values. The p-values indicate that which of the independent vector is significantly affect the dependent vector. So result indicates that weight is only one independent vector that affects the mileage significantly. Rest all independent vectors are insignificant. There is one more important point related to the coefficient of independent variables. Now you can see the HP and weight is negative. It means these two independent vectors are negatively associated with the mileage. Rest DISP, D-rate and Q-sec, these are positively associated with the dependent vector. And second important point is that the coefficient of independent vector indicates that if you make 1 unit change in the independent vector, how much change occurs in the dependent vector. So let's say if I make 1 unit change in the DISP, the MPG would be increased by 0.008 unit. Similarly, if I make 1 unit change in the HP, the MPG would be decreased by 0.02 units. Similarly, if I make 1 unit change in the Q-sec, the miles per gallon or the mileage would be increased by 0.6 units. So in this way, in your research paper or in your thesis, you are required to interpret the role of coefficients of independent vectors, and you have to mention which of the independent vectors significantly affect your dependent vector. Now next important point is multiple R squared value, that is 0.084. If you multiply it by 100, it will become as a 84%. Now this multiple R squared value indicate that these total 5 independent vectors explained 84% of the variance in the mileage. So this is a good indication for the regression model, and at last we have to interpret the F statistics value, which is related to the analysis of variance test. Now this value indicates that its value is 29.22 and associated p-value is less than 0.05, because if you solve this one 6.89 divided by 10 times 1 and along with 10 times 0, that will become as a less than 0.05. So this value should be significant, and it indicates that the regression model is good enough as compared to the baseline model. So in this way you can run the multiple linear regression analysis to find out the value of dependent vectors or forecasting the value of dependent vectors based on certain independent vectors. Thank you so much.